today we're going to talk about data collection. Also, we'll talk about how we organize the data and how we visualize the data. Before we go any further, let me introduce this acronym. It's called DCOVA, and we'll be using it for the rest of the textbook. Define the variable, collect the data, organize the collected data, visualize the data, analyze the data, and see if you reach at your conclusion. So that is the most important thing. And the next question is, what are the different sources of data? As I have indicated, we have a primary data source and a secondary data source. Primary data source is expensive, but it's more reliable, whereas secondary data source is relatively inexpensive and it's not as reliable. So you really question the source of the data. So the next question is, who collects data? And so again, data comes from all walks of life, from marketing to pharmaceuticals to financial to manufacturing, from the government, from all different trade groups. Everybody is interested in data because the modern society is a data-driven society. The more data you have, the more information you have. The more information you have, the better business decisions or life decisions you can make based on the data you have in your hand. So let's look at the different sources of data and how it is created. First of all, data is provided by individuals or organizations. It comes from design experiment, it comes from different types of survey, and also from industry, or also from observational study. So again, data comes from individuals, it comes from design experiment, it comes from survey, and it also comes from an observational study. When we look at data, there are two broad types. Numerical data, also called quantitative data, and categorical data, which is what we call qualitative data. What is the color of your car is an example of qualitative data. Have you been admitted to school? Yes or no would be an example of qualitative data. Now, if we look at data, it is generated from all different walks of life, as I have indicated. The next thing is to look at how we can make more sense of categorical data or qualitative data. If we have only one variable, we can use what is called summary table, and if we have more than two categorical variable, we typically use what is called a contingency table. So an example of summary table would be the type of payments. So payment is the only variable, and we find if somebody is paying in cash, in check, online, electronic, using Square. So these are different ways, and in this case we will use what is called a summary table. On the other hand, if we have more than one attributes, for example, there are two types of financial instruments, government bond and corporate bond, and then the other qualifier is whether they charge a fee, yes or no, So in that case, we have to use what is called a contingency table. Other examples of contingency table would be if you own a flat screen TV, and also if we divide between male and female. So if you are a male and you own a flat screen TV, if you are female and you do not own a flat screen TV, or vice versa. So that would be another example of a contingency table. Now let's look at how we organize the numerical data, or the data that we numbers. The easiest and the simplest way to organize numerical data is through ordered arrays, which means from an ascending order, from the lowest number to the highest number, and also from a descending order, from the lowest number to the highest number. So that's one way we can organize data. The other very popular way of construct is using frequency distribution. Frequency distribution is very popular. What we do with that, we provide a summary table in which data are arranged into numerically ordered classes. That's the second popular type. The third way we also deal with numerical data is what is called cumulative distribution. Under cumulative distribution, basically cumulative distribution is a percentage distribution that provides a way of presenting information about the percentage of values that are less than a specific amount. Again, it shows how certain values are less than a specific amount. So these are the two broad categories or ways we treat data. Now, when we look at frequency distribution, one of the important things that we deal with is the construction of class width, also called interval width. And this is very subjective. There is no rule of thumb that this is what the construct should always be at every time. We have a range, or we have a certain flexibility, and we have to operate within that flexible range. The way it is constructed is, for constructing a class width, we take the largest value, we subtract the smallest value, and the number of classes. And the conventional range is between 5 and 15, but again it depends on the data set. It can go higher or it can go lower, but the convention is typically between 5 and 15. And if you like to look at a contingency table, please go to page 29, table 2.3. That is an example of a contingency table. We have intermediate government bonds, we have short-term corporate bonds, we have fees, yes and no, and that's how you typically construct a contingency table. And if you like to look at a summary table, you can look at table 2.1 on page 28, different modes of payment. And that's the only variable, so we use a summary table. Now, going back to frequency distribution and ordered array, we can look at ordered array on page 32, with the city restaurant meal cost and the suburban restaurant meal cost is provided. Next thing we do is we put the data in an array form, ordered array, from the lowest price to the highest price. So in the city restaurant meal cost, the lowest price is 21 and the highest price is 79. On the other hand, if you look at suburban restaurant meal cost, the highest price is 68 and the lowest price is 22. And by the way, this is presented on page 33 of the textbook. Next thing we ought to do is we need to look at relative frequency and how we can use this information to construct the class width and also the relative frequency and also the cumulative frequency. So if you move on to page 34, table 2.8, they show how the table has been constructed. So the range in this particular case, the class width in this particular case is 10. The lower limit being 20 and the upper limit being 30 for the first row. And this is how we go down the list, and the last one is the lower limit is 70 whereas the upper limit is 80. Next to it is the city frequency and the third column is the suburban frequency. And once we sum everything up, both of them has 50 observations. So city frequency has 50 and also the suburban frequency has 50. Now when we add the two values within the class interval or the class width and divide the number by 2, we get what is called the midpoint. So if we add 20 plus 30 and divide that number by 2, we have 25. So 25 is the midpoint. Sometimes the midpoint helps you provide a graphical representation of the table in terms of a line graph or a scatter plot. So it has some usefulness, and that's why we sometimes are interested in knowing the midpoint. Now let's look at relative frequency. And how do we construct it? If you go on page 35, table 2.10, we look at the city meal cost and the suburban meal cost. Between 20 and 30, the relative frequency is 12.12. How do we arrive at that number? What do we do is, from the previous table with the frequency distribution, in the first row, we divide 6 by 50, and that's 12%. If you want to find out what is the meal cost between 70 and 80 in terms of relative frequency, in this case we divide 3 by 50. This is the last row, so that's 6%. And the next column, adjacent column on the right, indicates the percentage. 0.12 represents 12%, 0.18 represents 18%, and so forth. And the word of caution, when we are constructing the relative frequency, always the total adds up to 1 or 100%. And the same thing is applicable to suburban meal cost, with the relative frequency is 1 or 100%. And if we want to find out how many people, what is the meal cost between $50 and $60 for suburban, it is only 14%. So we have certain usefulness of relative frequency and proportion or relative frequency. And we will be using relative frequency when we deal with cumulative distribution. which is the next thing we're going to talk about. Again, cumulative distribution represents percentage distribution, provides a way of presenting information about the percentage of values that are less than a specific amount. So for example, if you are interested in finding out in suburbia or in urban area or in the city restaurants, how many meals cost less than $40. In other words, what percentage of meal cost less than $40 in suburban area, in city area. So if you look up the table on table 2.12, we can find out that number very quickly. So if it's less than $40, it has to be the first row and the second row, and once we add them up, it's 26%. So 26% of the meal cost in urban areas or city areas are less than $40. In a similar light, if you want to find out what is the percentage of suburban restaurants cost less than $50, in that case that would be 92%. Less than $60, that would be 92% for suburban restaurant. So in other words, there is usefulness and we of using cumulative distribution. And the next, and this is where I'm going to end this particular lecture. Thank you.